In the last video we talked about this formula, f of x equals a times the quantity x minus h squared plus k, and how it shows us what the vertex is at hk, and talking about shifting a parabola vertically and horizontally. So if you're not familiar with that, you may want to watch that first video. What I want to talk about in this video is what this value of a does to the graph. How does it affect the graph? So let's look at a basic example here. Let's look at our basic parabola f of x equals x squared. And like I said in the other video, if you're not comfortable with functions or working with functions, remember you can always just think of this f of x as y. This is the same as y equals x squared. And this one over here would be the same as y equals 1/2 x squared. Alright, so f of x equals x squared. If we have a table x f of x or xy, doesn't matter. Of course, if I'm using the formula f of x equals x squared, I probably want to say x f of x. And remember that if x is 3, all we're going to do is square that to find f of x, so that would be 9. 2 squared is 4. 1 squared is 1. 0 squared is 0. Negative 1 squared is 1, negative 2 squared is 4, and negative 3 squared is 9, which gives us our basic parabola by plotting these points. And this is a shape you want to be very, very familiar with and be able to recreate quickly, even without making the table, just by kind of doing it in your head. 1 squared is 1, 2 squared is 4, 3 squared is 9, so on. You wouldn't have to build the table. So now we want to look at what happens to this graph if we just multiply it by a half. F of x equals 1/2 x squared. So notice that the a value in this case, this light blue one, is 1/2. By the way, what are the h and k values here? F of x equals x squared. Well, if we wanted to really put it in this exact form, we could say that this was f of x equals 1 for my a value times x minus 0 squared, which just gives me x squared plus 0. So my h and k values are both 0, which corresponds with the fact that my vertex is at 0, 0. And the same thing is true for this light blue version here. The h value is 0 and the k value is 0. So let's go ahead and build the table. We know the vertex is going to be at 0, 0. And we want to see how the 1/2 affects what's going to happen here. So let's plot the same values. Okay, so if x is 3, we're going to take, remember by the order of operations, we've got to square first and then times by 1/2. So 1/2 times 3 squared is 1/2 of 9, which is 4.5. Alright, 2. 1/2 times 2 squared. Well, 2 squared is 4, and half of that, no, that's 4.5 dot, is 2. 1, 1/2 times 1 squared. 1 squared is 1, half of that would be 1/2. 0, 1/2 times 0 squared. 0 squared is 0, and half of that is 0. Let's plot these points and see what we've got, and then I want to talk about the negative values of x. So if x is 3, we have f of x at 4.5. If x is 2, y is 2. If x is 1, y is 1/2. And if x is 0, y is 0. Now to get these other values over here, which is when x is -1, -2, and -3, instead of going through the arithmetic of it all, remember the property of a parabola is it has a symmetry. You know, this half is going to be the same as this half. So we could just reflect these points over the y-axis, and that's called the axis of the parabola, which we'll talk about in a minute here. So -1 is also going to be up 1/2. -2 is going to be up 2. And -3 is going to be up 4.5. 3, 4.5. So we get a slightly wider parabola than we had with y equals x squared. this a value, being a fraction, creates a wider parabola. And we could experiment, with 1/3 and 1/4 and 1/5 and look for some patterns by building these tables. That can be a little time consuming. So let's jump over to a graphing function, which is going to make things a little bit faster here. So let's make this red one our basic parabola, okay? There's our basic y equals x squared parabola. Let's move this down a little bit. There we go. And we did 1/2. So we have, just to show what that looks like with this graphing calculator. Okay, so the green one is y equals 1/2 x squared, which is slightly wider. So let's make a smaller fraction. How about 1/4 x squared? What do you think is going to happen? Okay, there's the blue one is 1/4. It's even wider. Okay, let's get crazy. Let's go 1/20 x squared. Graph. So there's x squared, 1/2 x squared. Ooh, that yellow is kind of hard to see. But this is 1/20 x squared. So you can see what happens. It just gets wider and wider and wider. And that's going to, the smaller this gets, the closer this gets to 0, it's going to get wider and wider and wider. All right, well, what happens if this number in front of the x squared is bigger than 1? We saw what happens if it's less than 1. If it's a fraction that's less than 1, the parabola gets wider than your standard y equals x squared. How about 2x squared? Let's see what those look like. Okay, so this red one is y equals x squared, and 2x squared is going to be narrower. It's going to be a narrow or steeper parabola. If this number gets bigger, say 4x squared, the a value gets bigger, 4x squared, it's even narrower. And we could get, I don't know how this is going to graph. Let's give it a try. 20x squared. Is that yellow one? Yep, you can kind of see it right there. Really steep, really narrow. That's how the a value affects the parabola. Okay, so that's right here, this a value. Let's write that down. Just kind of write down what we discovered there. So let's see. If your a value is between 0 and 1, like 1/2, 1/3, 1/10, then you're going to get a parabola that is wider than your standard f of x equals x squared parabola. If your a value is bigger than 1, like 2, 3, 20 that we just looked at, you're going to get a parabola that is narrower than f of x equals x squared. Your basic standard parabola f of x equals x squared. All right, let's go back to the graphing calculator, and let's look at what happens if your a value is negative. So there's your basic x squared. What if I do -1, or just, I could have just put negative x squared, but let's say -1 times x squared. Let's see what happens. All right, that's a little, you can kind of see there what happens, but it's kind of, I'll move this down a little bit. So we have our red parabola is our y equals x squared, and then our green parabola is our y equals -1 times x squared. So it's the same parabola, it's just flipped over the x-axis. And that's exactly what's going to happen. Let's look at a couple different examples. Let's say I do 1/2 x squared and -1/2 x squared. So just remembering what we did a second ago, 1/2 x squared, is that going to be wider or narrower than the current red one, which is x squared? You remember? It's going to be wider. Okay, so graph, it's a little bit wider, but a negative, it doesn't change the shape, it just flips it over. Okay, so a negative a value is going to be an upside down parabola. Let's write that down. If a is less than 0, which makes it negative, then the shape is going to be this way, upside down. Okay, opening down is probably a better way to say it. Now notice it didn't affect, if a was negative, it didn't affect whether it was wider or narrower, it just flipped it over. So f of x equals 1/2 x squared, or f of x equals negative 1/2 x squared. Okay, wider or narrower than x squared, these two. Which is it? Well, your a value here is 1/2 and your a value here is negative 1/2. We know that if a is 1/2, it's wider. So this is wider than f of x equals x squared. And f of x equals negative 1/2 x squared is just flipped over, so it's wider as well. It's flipped over, but it's wider. So to expand our little definition here of a being between 0 and 1 being wider, we also want to accommodate the negative values of a, and we do that by saying the absolute value of a. If the absolute value of a, which means ignore the sign, okay, if it's a negative 1/2, just look at the 1/2, because the absolute value of negative 1/2 is 1/2. If the absolute value of a is between 0 and 1, then it's wider than this graph. If the absolute value of a is bigger than 1, then it's narrower than f of x equals x squared. And the only reason we have those absolute values in there is to talk about, these a values that are negative. Okay, so those are some important facts for looking at a parabola and being able to understand what's going on. Let's try to put all this together and let's answer some questions about a parabola. So let's say I have the parabola f of x equals 2 times x minus 3 squared plus 5. Okay, first question, what is the vertex? See if you can answer that. All right, the vertex, the h value, the vertex is hk. The h value, I have x minus h, x minus 3, so the vertex is 3. And the k value is 5, so the vertex is 3, 5. Let's see, is this going to be wider or narrower than your standard f of x equals x squared parabola? My a value is 2, which is bigger than 1, so it's going to be narrower. Oops, this is going to be kind of a steep parabola. Narrow. We'll just say it's narrow. And is it going to open up or is it going to open down? Well, if the a value is negative, it opens down. If the a value is positive, it opens up. I guess I could put that in there as well. If the a value is positive, then the parabola opens up. So our a value is a positive 2, so therefore it's going to open up. Let's see if we can do a quick graph of this. Yeah, I'm going to cover up part of that, but that's okay. That's all right. Okay, so we know our vertex is at 3, 5. So I can go over 3, up 5, and start there with my vertex. And I know this is going to open up and be narrow. I can't just go over 1, up 1, over 2, up 4 like I did before because it's not the same shape, it's narrower. So to find a couple more points, I'm going to actually do a table, or I could take my y values and multiply them by 2. But let's just do a quick table. So the vertex helps me pick x values. I want to pick an x value that's close to my vertex. I don't just want to go 1, 2, 3, okay? So my vertex is at 3. I want to pick either 2 or 4, 1 unit to the left or right. So let's go with 2. Okay, so now I've got to plug 2 in for x right here. I'm kind of running out of space. Let me see. Let me erase this stuff right here because we got our vertex plotted. We know it's going to be narrow and open up. Okay, so I'm going to plug 2 in for x. So f of 2 is going to be 2 times 2 minus 3 squared plus 5. Order of operations, I get negative 1 squared plus 5. Negative 1 squared is 1, so 2 times 1 plus 5 is 2 plus 5, which is 7. So over 2, up 7. Now, instead of plugging 4 in and getting a value, I can use the symmetry property of my parabola, and I know that this point is going to reflect over because this is my vertex. Let's talk about a special name for this. This is called the axis of symmetry. So right here where it's like a mirror. Where's the mirror for your parabola? It's going to go right through your vertex. So the equation of this line, since it's a vertical line, is x equals 3. And that's called the axis of symmetry. I'm going to run out of space. Symmetry. Did I make it? Not quite. There's a y there. Okay, I'll write it better. Let me write it again. Axis of symmetry. Axis of S-Y-M-M-E-T-R-Y. Axis of symmetry. So I know that I can, this point right here, this 2, 7, is 1 unit to the left of the axis of symmetry. So I'll go 1 unit to the right of the axis of symmetry and put another point. And that point will be on the parabola because of the symmetry of the parabola. It like folds onto itself. Okay, so now I don't want to pick 4 because I know what 4 is. So I either want to pick 5 or 1. Well, let's do 1. Okay, so I'm going to go back over here and I'm going to plug in 1. And let's see what we get. So if I put a 1 in for x, 1 minus 3 is -2. -2 squared is 4. 2 times 4 is 8, plus 5 would be 13, which is slightly off my graph, but I can fudge it a little bit. So 1 is 13, so I'd go over 1 up 13, say be about right here. Okay, so if I go, I'm 2 units away from the axis of symmetry now, so I'll move 2 units, I'll go to the axis of symmetry and then move 2 units to the right, and there'll be another point there, and this is my parabola right here. Okay, so that's a quick way to graph the parabola, find your vertex, and then use that vertex to pick a couple points that are smart to pick. I'm going to go ahead and go through one more example and give you a chance to work through it to practice, and then I'll go through it so you can check and see how you did. So what I want you to do is graph the parabola and using the properties of this equation up here and what A and H and K all stand for. Okay, so here's the formula I want you to graph, the equation I want you to graph. F of x equals -1/2 times x plus 3 quantity squared minus 1. So go ahead and pause the video and give that a try, and then start it when you're ready to go through. Okay, so the first thing we absolutely need to do is identify the vertex. So my HK value here, notice there's a plus 3, and in my formula I have a minus H. So plus 3 is the same as minus -3. Whatever your sign is here, you're going to end up doing the opposite, so that's -3. My K value plus K, but I have a -1, so this is the same as plus a -1. My K value then is -1. That can be a little bit tricky, but because of the formula, you got a plus K, so your K value is basically going to correspond with exactly what you have. We had a -1, the K value is -1. Because I have a minus H in my formula, then it's going to be the opposite of what it seems like. So I have a plus 3 here, and so my vertex is -3 for the x value. So I'm going to plot my vertex, -3, -1. Okay, I'm going to think of a couple things here. First of all, because there's a negative there, I know this is going to open down, so I'm expecting that. And it's a 1/2, so it's going to be a little bit wider than the regular x squared parabola. So I'm going to plot a few points. I want to plot points that are close to my vertex. I'm either going to plot -2 or -4. Those are each 1 unit away from my vertex, left or right. How about -2? So let's put in -2. So I'm going to do -1/2 times -2 plus 3 squared minus 1, which gives me positive 1 squared minus 1. So 1 squared is 1. 1/2 times 1, or negative 1/2 times 1 would be negative 1/2, take away 1 would be negative 1/2. So I have a point at, let's see, I put in my x value I put in was negative 2, and my y value I got was negative 1/2. So I have negative 2, negative 1/2. Then I'm going to flip this over my axis of symmetry, and I'm going to get negative 4, negative 1/2. Okay, so you kind of get 2 points for 1. Alright, let's erase this x value and do a different one. Let's put in 2 units away from my vertex, which is either negative 1 or negative 5. Let's put in negative 1. Okay, so if I put a negative 1 here, negative 1 plus 3 would be a positive 2. And 2 squared is 4, so I have negative 1/2 times 4, which is negative 2. Take away 1 is negative 3. Alright, negative 1, negative 3. Okay, my axis of symmetry is here. So I'm 2 units away. I'm going to go 2 units to the other side and make a dot. And that's probably enough to see what's going on. But 0 is a really easy one just to get another point. If I let x be 0, well, in this case it's not as easy because we've got, yeah, if it was a different form it'd be easier. It's okay. This is good. So let's go ahead and graph this, and that would be my parabola. Just like that. So it opens down, it's a little wider, and my vertex is at negative 3, negative 1. Alright, so you want to memorize this stuff up here in the box and the stuff in the purple about what the a value does and whether it makes whether the a value causes the parabola to open up or open down.